All right, welcome to 2.3 conditional statements. Here's kind of the main ideas. We want to analyze and write statements in if-then form. Write the converse, inverse, contrapositive of a if-then statement. So we'll talk about those individually, but here's your first slide. Again, go ahead, hit pause if you want to copy this down. We don't see the arrow too much. We usually see if P, then Q, or P implies Q. When we talk about a statement and the hypothesis and conclusion, what comes after the if is the hypothesis, and then what comes after the then is the conclusion. So that's kind of the main part of the hypothesis and conclusion of a sentence or if-then sentence. If you're a baby, then you'll cry. Again, the hypothesis, you are a baby. Conclusion, you will cry. Here we want to kind of write this. We might need to rewrite this as if-then statement, but hypothesis, you want to find the distance between 2 points. Conclusion, you'll use the distance formula. I don't think you guys have these, so I think I'll fly through this one. I know I cut some of these out. Yep. I'll leave them up there just in case I am missing them, but get the idea how to write an if-then statement if you use these. Good examples, I guess, to leave up here anyways during the video. So we're going to jump into Miss Orpin here. I think this is probably the first or the slide that you guys have next anyways, so that's kind of why I flew through those other ones. So Miss Orpin hurt her ankle. She went to the doctor, and the doctor said, hey, if you rest for 10 days, your ankle will heal, okay? So Miss Orpin rests for 10 days, and she still has a hurt ankle. What's the truth value of that? If that hypothesis, that's a true, that one actually matches, it actually rests for 10 days, so then the conclusion should match the same. Well, in this case, it doesn't, so that's where the conclusion is false. So therefore, this is going to be a false result, or not going against or going with our conditional statement. Where in this one, Miss Orpin rests for 3 days, she still has a hurt ankle. This one, the hypothesis doesn't agree. It's not 10 days. So therefore, if it doesn't agree, this is kind of where this gets true, but if it doesn't agree with the hypothesis, it's still true. And the way I kind of always look at this, especially when we're talking about days here, 3 days, well, she still has 7 days to get to 10, so she still has 7 days for the ankle to heal. So could it still work in 10 days? I say yes. So that's how I kind of keep this straight. So this was actually a true statement here. So therefore, we can't say anything about the hypothesis. So therefore, we can say it's actually a true statement just because the hypothesis is false. She rests for 10 days. She doesn't have her hurt ankle anymore, or her ankle doesn't hurt. So this one, the hypothesis is true, and the conclusion matches too. That's true also. So therefore, we're going to get a true statement because two trues. Miss Orpin rests for 10. Whoops, I'm not going to pull this up. She rests for 7 days, and she doesn't have her hurt ankle anymore. This is kind of very similar to the 3 days. Again, it doesn't match. The hypothesis is false, so therefore it automatically makes it true. Well, again, I kind of look at the days. 7 days is not quite 10 yet. It doesn't hurt at 10. Or at 7 days, well, as long as she doesn't go out and, overdo something and hurt it again, it should still not hurt in 3 more days. So when it comes at 10 days, she won't have a hurt ankle. So this one's a true statement also. So here's one to check on your own. If it rains today, Michael will not go skiing. It doesn't rain today. Michael does not go skiing. Well, a lot of people say, well, this one's false because we imply what's going on. But the hypothesis is it rains today. And this hypothesis, it does not rain today. So the hypothesis don't agree with each other. So it's actually true. I also think of it as we never said what Michael would do if it doesn't rain. It's kind of implied that, but skiing is just an option he could do that day is a way to look at that. So that's actually a true statement. It rains today. Michael does not go skiing. Yeah, that's a true statement because that's exactly how it says. It snows today. Michael does not go skiing. Again, hypothesis is false, but therefore it makes a true statement, so that's true. And then the last one here, it rains, but Michael goes skiing. Now it goes against the conclusion part, so this one would be false. Here's our converse, inverse, and contrapositive, and really it's this row you want to look at, and we'll talk about this in class too when you guys come into class. This kind of could be a very confusing part, but if you kind of keep track of the P and the Q, and we'll talk about how it flips around. So in the converse, we have a conditional statement. So we've been talking about conditional statements. So we have an if-then statement already. But if we look at the middle there, the converse is just flipping those around. So Q implies P, where it was P implies Q. So that's a converse. So then you just flip the statements around. So now the two angles are congruent, then they'll have the same measure. So you're flipping the whole if-then statement around. Again, the if stays where it is, the then stays where it was too. Inverse, now we go back to the original. P implies Q, but they're both the negations of, or not P implies not Q. So inverse is the not of the conditional. So in the example, you see the word not being added to the statements. And the contrapositive, again, all we're doing is flipping around, so therefore not P implies not Q, or not Q implies not P. So then we flip the conditional around there too. So let's try these in a couple ways. Again, feel free to pause at any time. All squares are rectangles. This is always a kind of a good debate in class to have, so maybe we'll bring this back up into class so we can talk about this. So if a shape is a square, then it is a rectangle. And that's our conditional. That's what we're going to work with. So that's actually a true statement. It's probably good to have a truth value to the conditional too. The converse, now remember the converse, we'd flip it around. So therefore, if the shape is a rectangle, then it is a square. And if we start saying that, well then every square is a rectangle, and every rectangle is a square, then why would we call them differently? So this one's actually false, because just because the shape is a rectangle, it doesn't mean it's a square. And if you think of it, think of a counter example. If I draw a real long rectangle, well, that's not a square, so that'd be a good counter example to prove that one false. Inverse, if the shape is not a square, then it's not a rectangle. And you'll find out that these two kind of go together a lot, because again, I could use the exact same rectangle to prove that one too. That's a shape that's not a square, but then it's not a rectangle. Well, that would be false because it is a rectangle. So just because it's not a square doesn't mean it can't be a rectangle still. So that's false. And the contrapositive, now we're going to flip them back around with the knots. I forgot to say that the inverse. Notice I underlined the knots there. Again, feel free to pause to make sure you get this copied down right. But contrapositive, if a shape is not a rectangle, then it's not a square. Well, and this one is actually true. And the conditional and the contrapositive will always kind of go together too. So if the conditional is true, the contrapositive will be true. And most of the time you probably won't see them all be false, but it could be. So try this last one example. Go ahead and try to do it through your own. This one's always fun in class when we have a foreign exchange student in class. It's always open to debate, but I always say if they're going to school here, they're living here at this time. So go ahead and pause, try to do it on your own, and then, or if you want to do it as we go through it here, you can do that. Just check if you're right. If you attend St. Francis High School, then you live in Minnesota. True. Converse, flip it around. If you live in Minnesota, then you attend St. Francis High School. here's why I always say people in Cambridge or Anoka or Andover would be upset at us if that's the case, or we would have a really large high school. So this one's false. Inverse, if you do not attend St. Francis High School, then you do not live in Minnesota. Kind of the same thing. Again, remember we said converse, inverse goes together. We could use the same counter example. Cambridge would be a good counter example, North Branch. So that one's false too. And the contrapositive, if you do not live in Minnesota, then you do not attend St. Francis High School. Well, that would be true because you're not going to travel all the way from South Dakota to come to St. Francis High School on a daily basis. So you could live here during the week at least, and that's living here. So anyways, that's 2.3 conditional statements. So hopefully that helps you out. If you have any questions, make sure you bring them to class. Hopefully you wrote them down on the side, and you can ask your questions when you come to class. See you then.